Real quick, who are we? I am Hayden Blauzvern. I'm a tech lead manager on Google's open source security team, and I talk quite a lot about public key infrastructure and transparency.
And I'm Colleen Murphy. I also work on the Google open source security team. I've been working in open source for a long time.
So here's the agenda for today. We'll talk a bit first about the motivations behind transparency. We'll talk about how we use transparency in Sigstore and some of the learnings that we've had from operating Rekor over the past couple years. And then I'll hand it over to Colleen, who will talk more about what we plan to do with Rekor v2. So let's first talk about why you want transparency in a system. The goal of transparency is discoverability and auditability of claims. Just because something is in a log doesn't mean that it's safe or secure. It's about that somebody can audit a claim that goes into a log. It forces malicious behavior out into the open. And when we talk about transparency systems, one way to describe what goes into the log is with this claimant model. There's a claimant, someone who is making a claim that goes into the log. That claim will be trusted by someone who's a believer, and there exists some verifier who can verify the truthfulness of the claim. So when we're talking about Sigstore, what that means is a signer is going to make a claim that they have generated some signature, and they are the verifier who are able to verify whether or not they actually generated that signature. And a believer is anyone who is installing binary or trusting an attestation that's been signed. So let's talk about how we might build a transparency log. So there's a few building blocks that we need. The first is that we need ways to efficiently compute inclusion proofs. These are cryptographic commitments that something's actually in the log. Without these inclusion proofs, there's no way for a believer to actually know that something was publicly available in the log so that a verifier can verify the truthfulness of that claim. We also need a way to compute consistency proofs. This is a way to prove that the log remains append only. If we didn't have consistency proofs, then the log might be able to tamper with or delete entries in the log. So typically the two data structures that we talk about to be able to build a transparency log are Merkle trees and authenticated dictionaries. We'll primarily talk about Merkle trees in this talk, and if you're familiar with blockchain, this is the same data structure that underlies blockchain as well. Proofs need to be tied back to the log somehow, otherwise it could serve you an arbitrary proof. And so for that, we need checkpoints, which are signed statements as to the current state of the log. And we also need what we're going to call a witness, which is an independent auditor for consistency of the log. And the role of a witness is to prevent what are called split view attacks, where the log presents different views to different callers. This is sort of the worst case thing that could happen to a transparency ecosystem. And so what we want is witnesses that are all independently verifying that they see the same state in the log. So the next couple slides, I'll go through this really quickly, the way that transparency logs with Merkle trees work. This is an example of one such tree. The leaf nodes are all hashes to the inputs, and then as we move up the tree, the parent nodes are hashed concatenations of their children. And what this structure gives us is the ability to very efficiently compute inclusion proofs and consistency proofs. Roughly the way that this works is if we rely on cryptographic hash functions, these are one-way functions, and I give you a list of hashes, I'm able to recompute from a leaf node up to the root of the tree, and this root is typically what is the checkpoint, which is the signed tree head for the log. If you want to learn a little bit more about Merkle trees, there's a lot of great blog posts online as well, and we're happy to chat more. So let's talk about transparency in Sigstore. We have a lot of trusted artifacts, and what we mean by trusted is signed artifacts that need integrity and authenticity. This might be build or source provenance, SBOMs, vulnerability statements, binaries or containers themselves. And as a signer, I want to know, for Sigstore especially, is my identity or is my key being used in ways that I don't expect? Remember, the motivation behind transparency is discoverability of claims. So one such question might be, did my identity get compromised? Or in the case of Sigstore, did the certificate authority, Fulcio, issue a certificate without my permission? Or have I built and released a package and generated an attestation that I didn't expect? So our answer to this is signature transparency, and our implementation is Rekor, which is our signature transparency log. Roughly summarizing Rekor, what goes into Rekor are signatures or signed events. And this signature might be generated with an ephemeral signing key, which is associated with an identity in a Fulcio certificate, or a self-managed signing key. And as we've heard in some of the talks already, Rekor also can provide timestamps, which will be able to verify these short-lived Fulcio certificates. This is an overview of the flow for uploading to Rekor. So I'm an artifact owner using something like Cosign or another Sigstore SDK like Sigstore Go, Sigstore Python, Sigstore JS. What gets uploaded to the log is roughly an artifact hash, a signature, and a verifier, which could be a certificate or a public key. And for this talk, we'll primarily talk about certificates. What gets returned from the log is this cryptographic commitment that something's in the log, an inclusion proof, a checkpoint, the signed statement from the log, and a signed entry timestamp, which is roughly a signature over a log index and a timestamp. We have this role of witnesses that are our append-only monitors, and then also the need for identity monitors, as we've heard in talks today, where artifact owners need to be monitoring what's going into the log to know if their identity has been misused. The takeaway from this slide should be that Rekor has a lot of components to it. We have the Rekor front end, which is how clients interact with Rekor. Rekor is backed by Trillion, which is a scalable Merkle tree service. And Trillion itself is composed of a log server, which is responsible for writing what are called unsequenced entries, or entries without a log index, to the database. And then a log signer, which is responsible for sequencing entries. And we also operate a search index so that you can look up entries in the log with partial identifiers like emails or subjects from attestations. So we've been running a public instance of Rekor for around 2 years now as in general availability, and there are many instances of Rekor being run in private environments as well. So we want to talk a little bit about some of the lessons that we've learned from operating Rekor, and we'll focus on 2 areas: API design and deployment learnings. So the first for API design is this trade-off of online versus offline. Rekor makes it fairly easy to be able to look up entries in the log, and early versions of Cosign and some of the other Sigstore clients had online lookups as part of this. Inclusion proofs were not persisted, as we heard in Zach's talk. The downside of this, of course, is that verification becomes an online process. So one of the learnings that we've had that we'd like to take into Rekor v2 is making sure that offline is the default. If you've written a Sigstore client before or interacted with Rekor, you might note that the API is complex. And this was intentional. Rekor has many different entry types. And the motivation here is this trade-off between every client having to implement logic for how to extract an artifact hash signature and a verifier versus doing all of this canonicalization. And by canonicalization, we mean taking these 3 fields and turning them into a leaf hash that goes into the tree. And doing all of that logic server side. So for example, for the Java ecosystem, if we look at a jar has an artifact hash, a signature, and a certificate or a key. So either we could have every client implement this, or it could be done server side. What we've ended up finding is that the 2 common types, hashed records and the DISI Rekor types, are sufficient for the vast majority of use cases. As I mentioned, Rekor supports providing timestamps, which can be used to verify short-lived certificates. We also have the search index, and some types in Rekor also support attestation storage, where we'll store the attestation that gets uploaded at the same time as the Rekor entry. The problem with this is these 3 things are necessary for an ecosystem, but not verifiable, meaning that the log could lie. The log could tamper with the timestamp or tamper with the search index without being verifiable. What we want is the log's purpose to be entirely verifiable. Inclusion proofs are verifiable, consistency proofs hold the log accountable and make sure that the log remains tamper-evident. So one of our takeaways here has been to think about how we make sure that we still support these services, but we make it clear this distinction between what's verifiable and what's not. The content that goes into the log is immutable. Once it goes into the log, it's there forever, which means that there is some opportunity for spam or user data that we might want to redact later. They'll go into the log. And so what we want to think about with Rekor v2 is how we can redact content up front so we don't have this concern of spam. And we want to be very privacy conscious as well. So we'll talk quickly about some of the deployment learnings as well. A big one is cost, and there's a lot of dimensions to cost. One is the deployment cost. Running a lot of these services is costly. There's the storage cost, the storage cost for the search index, the storage cost for the entries themselves. And there's another cost we don't sometimes think about, which is the cost to maintain these, the SRE cost. We heard earlier that we have this on-call rotation for running the public instance. It's staffed by engineers from 5 different companies who help contribute to Sigstore. And all of these things add up to both computationally expensive, monetarily expensive, and it's simply expensive to maintain. So with Rekor v2, we want to drive down this cost, this operational and this maintenance cost. As you saw from the previous slide, there are many components to Rekor. So we want to simplify the number of components that are necessary in order to deploy an instance. And we know we've received this feedback as well from those who want to spin up private instances of Rekor, that there's a lot of components. Witnessing is post facto, and what do I mean by this? If you get back an inclusion proof and then you want witnesses to independently verify consistency, a client has to go do that lookup. And what we found in practice is very few clients will actually go through with this process. So one of our learnings is to move witnessing more to a responsibility of the log, and Colleen will talk a little bit more about what that'll look like. And the last learning is that sharding is complex. What is sharding? A log grows over time, and you might need to create a new log so that it remains performant. Logs can also become corrupted, so maybe there's a database corruption such that we have to rotate in a new log. Rekor's API design tried to abstract all of this away, and what this led to is a lot of complexity. And so looking at the certificate transparency ecosystem, we have some takeaways here for how to simplify this. So now I'll hand it over to Colleen, who will talk a bit more about our vision for the future.
Thank you. So with everything that we have learned about running Rekor and using Rekor, we want to introduce what we think it should look like going forward. So the biggest change that we want to introduce is a tiles-based transparency log as the underlying transparency implementation for Rekor. The tiles concept is a relatively new storage system that powers some other transparency ecosystems like the GoChecksum database and some certificate transparency logs. Before, with Trillion, when a client, as Hayden explained, when a client needed to verify an inclusion proof, the log was responsible for finding each hash within the Merkle tree that was needed for the inclusion proof and serving each hash, that set of hashes, to the client. And that list would change as the log grew because the checkpoint would change. So with the tile-based log, we would offload all that work to the client. And in this system, the Merkle tree is divided up into subtrees that look like tiles. And the client then becomes responsible for determining which tiles contain the hashes it needs to build that inclusion proof. And so since the log is append only the rightmost tiles are ever changing. The rest are static, and therefore those are very cacheable. This design also happens to be a little more space efficient because only the lower level of each tile needs to be stored. The rest can be computed on the fly. Tessera is the new tiles native library for transparency logs. It was written by the same authors as Trillion, which is what Rekor is currently based on. And so they built in all their expertise and all their learnings from Trillion into this new library. Again, tessera is a library, so it's a Go library, and it's imported directly into the project. So the whole thing runs as one binary, which is different from how Trillion was working, which is two separate microservices, the log signer and the log server, and those had to interface with Rekor and the database. So it was all a little bit heavyweight and a little bit complex to maintain. Another difference was that Trillion depended exclusively on MySQL as its storage backend. The Tessera library has native support built in for a few different storage backends, and the team is working on adding more. So there's a lot more flexibility there. And the tile's design is kind of more naturally suited for like an object storage backend anyway, so that's kind of nice. And then Tessera implements the C2SP tiles specification. And so that means that we would have kind of a compatible transparency log API, and we'd be able to interface with existing witness networks that are implementing that same API. And one other thing is that tiles seems to be kind of the way that the transparency ecosystem is moving. So that's there's something to be said for just kind of staying current with modern technology. So in terms of Rekor, when a Rekor adopts tessera, we will have a number of benefits kind of automatically to address some of the issues that Hayden talked about. Since tessera runs as a library instead of microservices, that deployment will get a lot simpler. Maintenance of that deployment will be a lot simpler because it's only one process to run. Maintaining the tree by doing sharding should also be a lot simpler because with tessera, we're simply going to instantiate a new instance of the tree instead of having this complicated abstraction of like a virtual tree across multiple shards. So that process should be a lot easier, a lot less painful. And since those finished tiles never change, those tile responses are static, they're very cacheable. So we can improve response time by putting a CDN in front of Rekor, or witnesses could cache those tiles locally if they wanted to. And another kind of side effect of this is the tiles API should encourage more offline verification because that API doesn't have that inclusion proof endpoint. So we'll be kind of pushing clients to do more offline verification because that online lookup will be a little bit restricted. So tiles will help a lot with a lot of things. Moving to tiles, it'll simplify a lot of things, but we want it to be even simpler. We want it to be kind of a lot less fluff. And we want to make sure that everything that Rekor is doing is verifiable. There should not be any implicit trust in the system at all, as much as we can. So one of the things along those lines is to strip out any feature that Rekor, that isn't actually core to being a transparency log. So to that end, we want to split out the search index and the attestation storage, make those into separate projects, separate services. The reason for that is the responses from those services are unverifiable, meaning that the client just has to kind of implicitly trust those results. There isn't really a secondary way to validate those claims. So a compromised log could, in theory, lie about the existence or non-existence of something in these features. And we don't want Rekor to be part of that. We want Rekor to just be a transparency log, just do that one thing very well. And we don't want it to be misleading users about the other guarantees of its other features. So the search index and the attestation storage would become their own projects. A private deployer could choose to run one or not choose to run one if they don't need it. And the public good instance would run an instance of these services at a separate domain from Rekor, so it's very clear to users that it's not part of Rekor and it doesn't have the same verifiability guarantees. And so in the name of like simplifying things, we also want to simplify the API around uploading an entry in terms of the entry types. We don't really want Rekor to have to deal with parsing and canonicalizing 100 different types of artifacts, whether that's jars or RPMs or Helm charts or different attestation formats. We just want to reduce the overall surface area of the API and push that canonicalization back down to the client. And it kind of turns out, as Hayden said, that for the most part, clients are already kind of happy with this. They're already using a very small subset of the APIs or the entry types that Rekor provides. So it might be that offering them in the first place was kind of putting the cart before the horse, in a sense, solving a problem that clients didn't really need solved. So as Hayden said, we found through analyzing traffic on the public good instance that, at least for the public good instance, the hash record and disty types seem to be by far the most used. There isn't a lot of use for those application-specific types. So in the next version of Rekor, what we want to do is just make those the only types available, and that will simplify the Rekor code base a lot, remove a lot of dependencies from Rekor. And that will mean that clients now have to be in charge of canonicalizing those entries themselves into one of these types. So I talked a little bit about verifiability and wanting Rekor to be closer to a zero trust system. But one open question we have around that is with timestamps. So timestamps are currently generated by Trillian when an entry is integrated into the log. But there's not really a way for Trillian or Rekor to be prevented from lying about the time. And a timestamp is important for the Sigstore system because Rekor will issue a signed entry timestamp, and that's used to validate those short-lived certificates from Fulcio. So having that timestamp is just pretty critical. Having a timestamp from somewhere is critical to how those ephemeral signing processes work. And a lot of clients are relying on Rekor to be the one providing that timestamp. So handling this part properly is still a little bit of an open question we're working through. Timestamps are historically part of Rekor because of its relationship to Fulcio, but that timestamp means relying on just trusting Rekor system clock and trusting that it didn't lie about it. So we're exploring ways to remove this trust vector and make it so that you can actually verify those timestamps or corroborate those timestamps somehow. And we're open to feedback from the community on what you'd like to see, whether this matters to you, and what would make sense in your private deployment or what would make sense for you as a client of Sigstore. And then finally, we want to bring witnessing into the fold as a more fundamental feature of transparency. And we want to do this by introducing synchronous witnessing. So Rekor currently supports the idea of asynchronous witnessing, which means a witness can check the log when it feels like it, do a consistency proof out of band, and a client or a human user has to go look at the witness, see if there's any errors, and make some kind of decision on that. So it's a little bit of a manual process. With synchronous witnessing, the transparency log would maintain an active connection to a witness or a set of witnesses, and it would be able to trigger them to sign every new checkpoint. And since it has those witness co-signatures right away, it can then serve those as a response back to the client immediately. So that makes for a much better offline verification process because the client that now has the inclusion proof and witness co-signatures, and it doesn't involve any manual steps of checking a witness and seeing whether it likes the log or not. So if we want to call Rekor a proper signature transparency log, then having a robust independent witness ecosystem is pretty essential for preventing that split view attack. And having those corroborating witness signatures at verification time means that witnesses are more at the forefront and really more part of the verification process and brings Rekor closer to those zero trust ideals. So for Rekor v2, we want to start working on a protocol for Rekor to be able to connect those witnesses, for it to be able to discover witnesses, and make sure that you're able to include those co-signed checkpoints in the response to the client. And once we have kind of those building blocks, we will start evaluating a way to start bootstrapping a witness network, and also start talking about ways to implement or recommend a policy for verifying witness co-signatures. So those are a bunch of our ideas for where we want to go. So this will be a little bit more concrete about what the next steps we're planning on taking. So a design document is in the works. That should be out in the next couple of weeks, and then we'll have a few weeks for people to give feedback on that. We would love everyone to provide feedback on that. And once there's some consensus on this direction, we'll start implementing some of these ideas in Rekor, we'll roll it out to the public good instance, and then start thinking about where we go from there. So the changes for the immediate future will be definitely replacing Trillion with Tessera and working with the Tessera team on that. We'd like to remove the vast majority of those entry types and remove the search index and the attestation storage. And all of those steps should make the Rekor code base a whole lot simpler, a lot easier to maintain, a lot cheaper to deploy and manage. And then we want to add the ability to have that synchronous witnessing, make sure that Rekor is capable of that. And then we'll be working on all the clients under the Sigstore organization to make sure they're all ready for all these changes. And then once we have kind of an MVP with those changes, we'll start rolling this out to the public good instance. We're not going to take Rekor v1 away right away. We'll just be encouraging clients to start migrating to the new instance and smoothing out any road bumps that might occur as we do that process. And then when it comes to witnessing, there's a bit of a chicken and egg problem with wanting clients to have a robust policy on verifying witness co-signatures, but we don't have that witness ecosystem yet, and we can't have that witness ecosystem yet because Rekor doesn't support it yet. So we're trying to get the ball rolling by building that support into Rekor, and then we'll start thinking about next steps for encouraging independent operators to run some witnesses, and then thinking about how to create verification policies for those. And having a C2SP conformant witness API will mean that we can interface with other transparency ecosystems like binary transparency, key transparency, certificate and transparency, and those do have some witness networks already. So that will allow us to work together more closely, which could be a big benefit for everybody. And then our big hope with Rekor becoming smaller, simpler, cheaper to run is that we might be able to start having some more independent log operators run their own transparency logs and eventually have a more diverse log ecosystem, which would be great for everyone. Going forward after that, we decided for now we don't want to pack too much into this immediate next version of Rekor. But there's still a lot of changes that we want to make to Rekor down the line to address a lot of the issues that Hayden brought up. A big one is hashing entries, making sure there's no plain text data that gets persisted to Rekor. And that would be for the sake of privacy protection and spam mitigation. We're kind of holding back on that for right now because FullCO has the same problem. It has its own transparency log. And so we want to make sure when we're rolling out a solution, we're rolling that out in lockstep with both services and solving it for both services. We also want to adopt Tessera in FullCO. It again has its own transparency log, so it should get the same benefits that Rekor will get by adopting Tessera. And then finally, we kind of need to figure out what we want to do with the Rekor v1 instance and how to start turning that down and what to do with that data. So one thought is to maybe add a compatibility layer in Rekor v1 to serve that existing data as tiles. And that way, the data is still accessible. If you don't have your offline proof material available, you can still find it in that Rekor v1 instance. But it would be hopefully simpler to maintain, cheaper to maintain, and a little bit faster. So we love to get your feedback on all these ideas and get any of your ideas for how you would like to see Rekor run. So please feel free to come talk to us. And thanks for your time.
So there are two questions. One question about how the caching works for tiles, and then the other question around what policy might look like.
So in terms of caching, so the tiles would be stored as kind of a static, like either an object or a file often, and so we would just plan to use a CDN in front of those. Or optionally, like a witness could fetch those and just cache them locally if they wanted to, if that made sense for that system. And then what was the other question?
So you were wondering about what policy? Yeah, so I guess I would say that policy becomes easier to author with less types. Right now you have this concern of there's an explosion of types. You need to understand how to parse every single one of them, where to look for things like identity or a public key identifier as part of it. So I think policy becomes simpler to write with less types. I'll also say that Sigstore has never been very opinionated on what policy language somebody uses in order to do verification. We do have a policy controller, which is a Kubernetes admissions controller. And I know over the last couple days I've had some talks with folks as well who are thinking a bit more about policy. So I think it's something where maybe Sigstore might have a recommendation, but I'd love to look to the community for more ideas about how to write policy and what works best for them. So 2 questions. The first, what would be the migration path for private deployments? And then the second one is, do clients like Cosign or need to be updated in order to support this?
Can I take that?
So for the first one, it depends. So if you want to upgrade to Rekor v2 in your own system, I think it should be relatively straightforward. Part of this, so these are, I think, somewhat linked, right? The first, to the second question. We will need to make client updates for the write path that they start writing to the new API. We don't think these are going to be significant changes to make, but there are some changes that need to be made. I'll mention that the biggest change would be more on the monitoring side, because the way that you access the log is very different. So if any clients are currently doing online lookups, switching to offline verification is going to be a change, but this is something that's built into Sigstore clients already. And the offline verification path should remain the same. So I think to your question about how to update, either you can switch over to Rekor v2, and if you're using something like Tough, you can distribute the new URLs. This is actually one thing some of us were chatting yesterday in a client meetup about, that there's a few open questions still about how best to distribute these new URLs in a system. But for a private deployment, I think it'll be a little bit easier to do so. And then, as Colleen mentioned, we're also giving some thought about how, if you needed to still maintain Rekor v1, you might be able to migrate over to a tiles-based backend, so you still get the benefits of cacheability, minimized cost and maintenance, but still maintaining the API. But I think the work should hopefully be done largely for you as part of upgrading clients. Was there anything you wanted to add? So the question was, can we simplify even more? Can we go down to one Rekor type, like hashed record, rather than also maintain DISI?
I think that's more of you.
Maybe. So when we had started talking a little bit about this design, we could simplify more. And again, we're just, that trade-off there is we are pushing the attestation canonicalization logic down to the clients rather than have it server side. I think we could do it. I think maybe this is an area where I'd love to hear more community feedback. I'll mention, just so folks have some context, the DISI Rekor type is a little bit different than the in-toto Rekor types, which came before it, which also had some attestation storage. So the DISI type removes the attestation storage. So roughly these types look very similar except for this additional canonicalization. So I think it's something where we could, but if, given we see a lot of clients already using the DISI type, we wanted to maintain that. So the question was, if we're moving to a tile-based system, do we remove the need for a relational database?
So yes, so tessera currently supports POSIX, MySQL, or GCP, which currently uses Spanner and GCS, and I believe they're adding support for AWS as well, and they're probably open to feedback for others, other storage systems. So yes, you wouldn't have to use MySQL anymore.
And one thing to mention is the way that the databases are used currently are roughly as a temporary storage where these unsequenced entries will go in before they eventually get written to object storage as part of tiles. Yeah, the question is, are there specific performance benchmarks that we're looking for?
So I don't have those numbers, but I can connect you to the tessera team, and they have some ideas on like the performance numbers for the different backends. So
And-
maybe
and-
that's something they're thinking about.
Yeah, and I think we'll be doing some exploration as well, exploring different backend configurations.
We'd be interested potentially in helping with performance benchmarking.
Fantastic. Let's chat more. All right. Well, thank you, Colleen.